Oh, is it? Oh, oh, okay. Okay, so I'm Aaron, and this is my individual portion of the final project. So basically, for our project, we wrote a code that would solve any Sudoku grid, and my individual portion of the project was to display this grid in the Snap window with costumes, etc., etc. So I'd like to start off by showing I had to import this, or by showing this, I had to import every single icon of representing numbers 1 through 9 and a target, which I'll get into more detail later. But the target represents blank spots of the Sudoku grid. Okay, so basically this block right here takes in a 9-item list, and of that list, each item of that list is a list containing 9 items. So as you can see, each list is has 9 items, and it represents a row. So every row, so if you look at the sprite, I'm moving the sprite, and that represents a row, and then where I'm moving the sprite, that represents a second row, and then so on. So each list here, from left to right, represents a row. So the list on the farthest left, so list with 7, 5, 3, 8, 4, 9, 6, that represents the first row. The second row is the list with 3, 4, 9, 6, 7, 5, 9, 8, and then the third row is the list with 8, 6, 4, 5, 9, 7, 3. Okay, so before I get into more detail about the code, I'll show you how it's incorporated in the code, or in the general code we have. So basically, you click the green flag, it clears the snap window of any drawings or any other stamps that have already been made, and it sets this universal variable of total grid to an appended list of length 81. And it's kind of weird because this is what happens when multiple people do different parts of the code. It's really hard to keep everything, have everything, when you put everything together, when you put every person's part of the code together, it's really hard for everything to run immaculately, because we all write different parts of the code, or with different variables, different ways in which it's made, or which it's coded. So basically, Caroline appended a list of length 9 to a length 81. So as you can see in the snap window, this list has 81 items. But then my block, it takes in a list of 9. So a list of length 9, and each list is a row, or each item of the length 9 list is a row. So basically what happens is, at the beginning it will, so it goes through the first 4 blocks, and then it goes to the stamp numbers for Sudoku grid block, and this will basically divide total grids into what it was before, a list of length 9 containing a list in each item that is a list of length 9. So basically it does that, and then it stamps the grid of the non-completed Sudoku grid, and then once it solves the Sudoku grid, it will then stamp the numbers for Sudoku grid it'll basically stamp the completed Sudoku grid with all the answers. Okay, so I'll get into detail about the code now. So this code basically here I'll go to edit. It basically is a list, or it's a block filled with for and if and else blocks. So I'd like to start out by looking at the first 3 blocks. So clear, as I said, we'll clear anything that's previously on the snap window. And I made the universal variables of y and x, which represent the starting position. So x is -160 and y is 155. As you can see where the sprite is right now, which is the target, that is where the starting position is. So I had to experiment with what coordinates I should use and what represents like how far a block is away from each other block, so I could stamp. So at first it starts out at the starting position. So the next block is the biggest for block, and it's as I explained in my individual reflection, the first for block is basically a block that iteratively goes through every single item of the grid list. And remember, the grid list is length of 9 with each different list. So basically, what this first for block does, it's gonna break up the length 9 list into 9 different lists, and it's gonna apply everything within that for block to every single item of the grid list. So basically, it's gonna apply whatever's inside this for block to every row. So I basically split up. For my stamping, I split up everything by row, and the stamping is done by row. So inside the first for block, I have a script variable a, and I set a to item 1 of grid list, which so basically so a represents item I1 of grid list, which is if I1 equals 1, then it represents the first row. So this next for block I2 basically goes through every single item of the first row. Every single item, or it goes through item 1 to length of a, which is basically item 1 to length of the row, which is 9, and it checks if each item in a is a number, and if it's not a number, it replaces that item with the number 10. And it basically makes it easier for me to recognize what a blank block is and represent that with a target, as you'll see later. And then the next block is switch costume to item 1 of a. So if since a represents the row, it switches the costume to item 1 of a, and item 1 of a is a number 1 through 9. So if item 1 of a was 1, it would switch the costume to costume 1, which, as you can see here, costume 1 is number 1, or is the picture of 1. Okay, so the next block is the if and else block, and the if and else block, it checks for every, so if I1 equals 1, so remember, this block is dependent, the if and else block is dependent on the first for block I mentioned earlier. And this block essentially changes the y coordinate, so it basically distinguishes rows between rows. So this is kind of a base case. So if I1 equals 1, then it's going to go to the original starting position of 155, or -160, 155, where the sprite is right now. But if I1 is greater than 1, which means that it's going to another row. So like I said earlier, I1 equals 1 is the first row, I1 equals 2 equals the second row, because every item of grid list represents a row. So if I1 is greater than 1, then it's going to go to X comma, y minus I1 minus 1 times 40. So basically, in the else part of the if and else block, it goes to the starting position, but proportionate to the y position. So it basically, if I1 equals 2, then it's basically going to move the sprite 1 down, as you can see in the snap window. So where the target is right now is going to represent I equals 2. Okay, so the next for block, which is the third for block, is basically the stamping block. So once this block knows where the starting position is and know what row it's in, it goes to the stamping. So I did for I3 equals 2 to length of A. The reason why I started it at 2 is because, as you can see in the block, it stamps twice. So if I started it at for I equals 1, then we get this problem where we'd get another stamp where my sprite is, which is not in the Sudoku grid. So basically what it does is it looks at every item of A, and then it changes the costume accordingly. As you can see, I changed X by 40, and that was just the number I calculated to distinguish between each box. So the length of the difference between box 1 and box 2 is 40, where I want the stamp, essentially. So it stamps 1, and then moves to the next, change X by 40, moves to the next box, switches the costume to the next item, and then stamps that item in the next block. All in all, this was the hardest part of this was basically using the costumes, I think, because I don't have a lot of experience with costumes, but all in all, it worked out. And you can take you can actually essentially take any length list and have this block dissect it and stamp for each number if the numbers are 1 through 9. If you had more numbers, you would need more costumes. But for the case of Sudoku, I only have 1 through 9. Sorry. In the second block, or in the second for block, I2 equals 1, I change blanks to the number 10, and then the number 10 represents, as you can see in the costumes, the target is number 10. So when it sees the number 10 in the for I to 3 equals 2 to length of A block, or this third for block, it will it will stamp the target for any number, or for it'll stamp any number, or it'll stamp the target for an item that equals A, or that equals 10. Okay, so let's see what the block does. Okay, so basically here's a sample list, and this represents a Sudoku grid. And here, I'll just show you what it does. So look at the sprite window when I click this. Yay! Okay, see? Where the blanks are, the target is, and look, see? Here. See, in the first list of, in the first list of this whole list, in the first item of this whole list, you see that the list goes blank 753, and then on the Sudoku, or on the snap window, you see target 753 target. So it basically fills in the blanks with a target, and fills in the numbers with the respective sprite, or respective costume. Okay. Cool.
Hey! After him!